Bismillahirrahmanirrahim. In this short video, we'll solve a problem and chapter problem from chapter number 13. Problem number is 1313, and this is on the request of a student from Bangladesh. Okay, so the question is, for the circuit, determine the impedance seen by the source. Now, what does this mean? This is the source, so whatever is the impedance at this point, that we want to find out. And this impedance is called Zin. So we'll do it by two methods. First, we'll do it by the mutual inductance method. And in mutual inductance, this type of circuit. So in our circuit also, we'll draw the current I1 and I2, and then we'll draw another circuit where we'll accommodate the induced voltage, mutually induced voltage. Because of I2, the mutually induced voltage in the left hand side, primary side, and because of I1, the mutually induced voltage in the secondary side or right hand side. Now, first of all, just see the magnitude. This is the j omega m, or the mutual inductance. So this J2 multiplied by I2 will be the voltage induced in the primary side, and similarly J2 multiplied by I1 will be the voltage induced in the secondary side. Now, what about the polarity? We have learned in my earlier videos, I have explained it in detail. Here, let me just repeat it. Current entering the dot. If the current enters the dot, like here, this current is entering the dot, then mark positive at the diamond near the other dot. So if we have a diamond here, then we'll mark positive near the dot, that means towards the upper hand side, towards the upper side, and negative towards the lower side of the diamond. But if it is not entering the dot, if the current is leaving the dot, then mark negative near the dot. So let's see now here. This current is leaving the dot. So dot, now in this case dot is up. So upper side will be negative. So upper side is negative and lower side is positive. Same here. Current is leaving the dot. So dotted side, that now in this case dot is at the bottom. So the bottom side will be negative and the top side will be positive. So this way we have marked the induced voltage direction, and now we are ready to write the equation. So for loop 1 we can just write that the input voltage 80 and 4 plus J5 is multiplied by I1. So 4 plus J5 multiplied by I1. And this one has a positive sign when we are coming from here, so we'll write positive J2I2. So positive J2I2, this is our equation number 1. Similarly, we'll write equation on the secondary side. We can start from here, so positive sign, so positive J2I1. Let's see, positive J2I1 plus, now I2 is passing through all these. So J5 plus 4 plus minus J1 plus J2. J5 plus 4 minus J1 plus J2, they will all be multiplied by I2 to get the voltage. So this is the second equation, and we can simplify this. And so the final second equation will be like this. So J2I1, and from here we get 4 plus J6. Now from this equation we can find I2, and then we plug in that I2 here, so we'll get everything in terms of I1. Okay, so these were the two equations. From here now we'll get I2. So I2, we move this on the other side, and then we calculate I2. So I2 will be minus J2 divided by 4 plus J6 into I1. So we now plug in this value here. So our equation will become like this. Now everything in terms of I1, and this is V. So V over I1 we want, so we take I1 common. from the right hand side. And one more thing here, I'll just trying to explain. Some of you might be confused still about the multiplication with j. So look here, this is j2 multiplied by minus j2, j2 multiplied by minus j2. So we have a minus sign, then we have a j square, and then we have 2 into 2, 4. Now this j square itself is minus 1, so minus minus plus, so the net answer will be 4 at the numerator. So now it will be 4 divided by 4 plus j6, and now we can bring I1 here to find the input impedance. So Z input is V over I1. Now this is I1, this is V. So V over I1 is 80 over I1, and it is equal to this part here. And again, we can now use the calculator in complex mode to solve or get the answer directly. So if you still have doubt about using the calculator in complex mode, I have a video on this topic, so kindly go through that video. Okay, so the answer will be 4.308 plus J40538. Now we'll do the same problem with, through another method, which is a lot shorter. That is called the linear transformation method. So this is the circuit. Here also we add the diamonds for the induced voltages, and I hope you can now follow. Now here current is entering the dot, so the dotted terminal, that is upper part, will be positive and bottom negative. Here current is leaving the dot, so the dotted terminal, that is the upper part, will be negative and positive, and j omega m1 and j omega I1 and j omega I2. Okay, and from here we can write this equation, the voltage equation for the loop 1, R1 plus j omega L1, and this voltage with the minus sign, and similarly on the other hand side, minus j omega M1 and I into all these three terms, as we did in the previous slide. And from here again we'll calculate the value of I2 and put it in this one to get in terms of I1. So when we do that, we find V over I1 to be like this, R1 j omega L, this remains same, and this while putting the value, this term will be something like this, omega square M square divided by R2 plus j omega L plus ZL. So now if you are able to derive this, or if you remember this formula, then you can directly put the value. Now this is equal to Zn, and now this is our question. So we'll simply, if you compare with these, you can straight away put the values in this formula, and we get the answer. So R is 4, this is j omega L1 is 5, this part we found out to be 2 square, and then R2 and j omega L2 and ZL, and solving we get the same answer, 4.307 plus 4.5381. So I hope this gives you an understanding as to how you can solve end chapter problems like this. Thank you.